Yeah, that's the only reason I'm doing all of this, because I'm bored right now. Let's just start. You're given two non-empty linked lists representing two negative integers. Okay, so the digits are stored in reversed order. So you have two linked lists. Uh, these are integers, right? Non-negative. Cool. The digits are stored in reverse order. So this we have 2, 4, 6. Then that means this is okay. Wait, what? And each of the nodes contains a single digit. Okay, fine. Add the two numbers and return the sum as a linked list. That's just like an adder sort of thing. Assume the two numbers do not contain any leading zeros except the number 0 itself. So if you have like 2, 4, 3 and 5, 6, 4, the output is 7, 0, 8. So first they did 2 plus 5, then that's 7, 0 carry, 4 plus 6 is 10, 1 carried 0 there, and so on. And yeah, that's all there is. This is easy. Come on. I mean, what even is this? This is just like, yeah. So you have list 1, list 2, you have list mode. So the value, the next, etc., etc. So while both of these are there, that is list 1 and list 2, first you just want to have the sum. So um, I'm thinking, okay, so you want to return what? You want to return a linked list, or yeah, return the sum as a linked list. So I'm going to make a new one, I guess. Yeah. So I'll just say S is, uh, you could start at a Sential node, right? Yeah, so that you can just keep on, or you could start as a first node, because if there's nothing, then it's a 0, right? So let me just keep on doing that. Okay, I'll just start with none, right? Okay, cool. So first thing first, if both of these are null, in that case you just return 0, right? Yeah. So if wait, so what do you return for 0? No leading zeros except the number 0. Oh, so if one of them is a 0, because it's not negative, so it's going to be like, oh, it's impossible for it to be null. Fine. So we can start with like that. So the sum will be none. And now, yeah, you just want to go piece by piece. So in the reverse order. So 2 plus 5 should be 7, like that. Yeah. And then as it moves forward, you want to add something to it. So you want to, okay, fine, cool. So while L1 and L2 is just 2 pointers, right? Yeah, so you want to append an extra thing. So this will be like, so you keep the S thing there, and you'll just be like the tail. So tail is also just S right now. So what we'll say is tail dot next is a new node, right? So while this is not null, so is not null, 2 is not null. Just doing this, we don't want to mess that up, because that happens sometimes. Wow, I'm really slow at typing, am I not? Fine. So tail dot next is equal to just a new node. So I'll be like list node. I'm assuming that's how. Okay, and then the value, which will just be L1 dot value plus L2 dot value, right? Yeah, plus the carry. So carry will initially be 0, right? Yeah, actually let's kind of see what this value is first. So I'll be like v is this thing. Now c is just v remainder, no, not remainder, division 10, and then v is just v remainder 10, right? So just whatever is the remainder, fine. And now I can do this thing. So this will be tail dot next is new list node with this value v, and then the carry is updated, whatever. Right, and this will happen till L1 is not null. Yeah, okay. Then one of them will be null. So let's assume that L1 is, so okay, L2 is, so L2 is not null. So here I already assumed, so that means the other one is null. So you just keep on doing it. So if that happens, then all you have to really do is just attach this one. But okay, am I allowed to? Is that a correct thing to do? Hmm. Do not contain any repeating zeros, non-empty linked list, represented, etc., etc. I mean, you could have a carry, and then that's a problem. So it's better to just keep doing this. So it will be like v equal to L1 dot value. So L2 dot value is just not there anymore because it's like exhausted itself. So now it's all zeros from there. The C, right? Just carry on, and then C is, uh, yeah. So this goes on till it's null. So you hit a null, and now you still have a carry, right? Mm-hmm. Right. So you still have to put the carry there, but we'll do that at the end. So C is just that, V is V remainder 10. The same as before, exact same logic. Tail dot next is just list node and V. And we'll just copy this thing. It's the same thing for if the other one is there, right? So while L1 is not null. Just keep doing this. Now you have a carry which you have to somehow deal with. So if C is 0, so if C is bigger than 0, right? And notice it's always going to be bigger than 0 because it's a remainder, right? If the carry somehow happens to be bigger than, yeah, I mean, it's always going to be positive. In that case, you just add this. So you're like tail dot next. Oh, I'm by the way missing something important, which is that I have to increment tail as well. So tail dot next is equal to list node, not V but C, right? And yeah, you also have to do this thing. So tail is tail dot next, right? I'm thinking maybe I should have assigned this to something and then I could have just directly done it, but whatever, this also works, right? And I also have to make these guys go forward. So L1 equal to L1 dot next. Wow, I am really bad at coding, or maybe I just got used to VS Code. Okay, so L2 equal to L2 dot next, etc., etc. Because L2 is not none. Oh, okay, L2, oh, this is bad. So while L1 is not none, because yeah, you're iterating over L1, right? That was bad. And here, while L2 is not none, we are just iterating over L2. And so you'll just do L2 equal to L2 dot next. Fine. And so if both of these are not there, in that case both are null. So just tail dot next is this list node, and then yeah, that's pretty much it. Because tail is like whatever is the last thing, and you know that this is going to have null as the value, so it's fine. Right. So right now it's just tail, but okay, you want this next thing to be there. So you will have to have a Sential node. So I'll just say it will be like a list node, and I'm just going to give it some value. So like some, I don't know, start token, whatever. So yeah, that does it. Yes, that's the thing, right? Because it doesn't have an extra. So yeah, and then what? Just wanted to say as to it's not next, because yeah, clearly, and you just return S. It shouldn't be too hard. I think that works. Let's try to run this. The good thing is it runs on a server, so it's like none of that is going to be happening here. That's nice. So yeah, it's running as expected. I'm gonna submit and see what's. Uh, yeah, the usual. Next. This wasn't even a medium level. It's just like boring at that point. Okay. So filter. Yeah, I want unsolved. So to do. I want medium. Let's do like 3 problems and then stop because I do have to sleep. I don't want any specific topics. Anything. Give me anything. The point is to learn, right? Okay. What is this thing? LRU fish. Oh, it's that thing. Ah. So I struggled with this some time before, but now I guess I'll be able to do it because I've taken an operating systems course. So design a data structure that follows the constraints of least recently used cache. Yeah. Uh, so basically the thing is you just given a sequence of numbers or items or whatever, and you have a bunch of slots. So like whenever your capacity is like going over it, right? What you want to do is figure out the one which is least recently used and then eliminate that. So the usual way to do it is using a doubly linked list. Have they done the doubly linked list? No, they have not. So we'll have to do it by ourselves. Okay. So initializes the LRU cache with positive integer size capacity. So this get returns the value of the key if it exists, otherwise -1. Right. What is that? Oh, okay. So it's a cache. Fine. So yeah, okay. Put, it updates the value of the key if the key exists. Otherwise, add the key value paired to the cache. If the number of keys exceed the capacity from this operation, you evict the least recently used key. Yeah. So you can think of it as a dictionary. That's one thing. Like every cache is a dictionary in the end. I mean, a dictionary is basically a cache. Whatever, you know the thing. So that takes care of the cache part. The part is the eviction, right? So for eviction, good question. I think the default dictionary thing has a limit, right? Yeah. But we'll try to do it with just normal dictionaries because I don't remember the syntax for that. But yeah. So capacity integer. Okay. So you will just need like a bunch of these guys. Yeah. Key value pairs. So for each key, you want the key to be stored in a doubly linked list, and then yeah, you actually want so the node will actually have the key as well as the value. Right. Is that correct? Yes, I think so. So that whenever you want to refer to a key, okay, or a value, you'll just look up the thing from your hash table. The hash table will have the nodes, right? It will like the values are basically the nodes. And then whenever you want to evict something, you just look at the least recently used one. So since it's a double linked list, you just assign one end as the least recently used, one end as the most recently used. Evict that one, right? Basically remove it from the hash map and also remove it from the linked list. It's a double linked list, yeah. And then whenever you use something, you want to move it. So you basically join and then, yeah, add it, right? So the hash still is there, right? It's still pointing the same thing, except you have just changed the position. Yes. So then it's just like order 1 removal because you already have the cache over there. Yeah, this should be easy. Before this, we'll need like a class for node. Okay, do we really need a node? I mean, it makes thinking easier, so I guess we can do that. So yeah, class, it has an init. The things that you'll be taking in are just like keys and values. So self key and the value, right? Yeah. Just like do the thing, right? So self dot key equal to key or whatever, self dot value equal to value, and you should give it some initial value. So let's just say this is none. I mean, you need some sort of key to be doing a node, right? Does a sential node make any sense? Well, you would need a sential node actually. What are the kind of things that you're getting? Okay. So we just want to implement the class. This is like not important. So initially it just had 2 as the thing, that is the key, and then it's saying put. So put 1 1, I'm assuming. Wait, what? Just put on page 1 and sorry, put on the key 1 and once again on the 1 and 2 and 2 and get 1 and put on 3 3 and etc etc. Right. I still don't know what's going on over here. The output is null. Okay, so it's just initialized, so it's null. Put is like null as well, so you just did 1 1 and that's still null. This is null null. Get, for 1 it's 1. Wait, what? Oh, okay, so this is like, it's a tuple, right? For put you require a, yeah. So first it was just a initialization and I just did 2, so it's just like that. And then put, at 1 you did 1. Wait, but you don't have anything for 2, so how did you, why is this just LR Yukesh? Huh. Oh, okay, so it's the capacity is 2. Fine. Positive size capacity. Fine. Okay, I get it. Uh, just to self dot value, self dot key, whatever. Define, not define, sorry. And I also need a next and previous, right? Okay, so next will be, or left, right, or whatever. Or let's do like more and less. So more recent and less recent, right? Just so that it's like easier. Fine. We don't really need anything else, do we? But we could add some methods. We could add like a joining method or something like that. So we could be like, I don't know, pull. So it will be like pulling on both ends and then joining it together. So you just require left self. And yeah, that's pretty much all you require. So you'll be like, the thing which is on the more end and on the less end, you'll just join it together, right? Yes. So self dot more dot less. Firstly, these have to be null values. Okay, yeah, right. What happens if it's just a null? Right. So it'll be like more equal to self dot more and less equal to self dot less. If more is not none, in that case, what you'll just do is like more dot next. So more dot less equal to less. Yes, I know this is confusing, but trust me, this is like not confusing for me, and that's what matters. Less dot more equal to more, and yeah, just return the thing itself. So return, or don't return because you already have a reference. That's why we're calling it. And so okay, what this does is like combines the thing, and yeah. So now you just have to detach the thing, right? So self dot more is none, and self dot less is none. So now we've like lost the references completely. Fine. Right. So if it's not none, we'll just do that. If it's not none, we'll just do that. It shouldn't be hard. Yeah. This one is okay, I think, because you will have necessarily something on both sides. You could have none, and then yeah, that was, it's okay. Fine. So let's start. So how do you initialize empties, right? Nothing over there. So we'll just be like self dot dictionary. So we'll just like call it a D for dictionary, and you just have nothing over there. Your linked list is also something that you have to have. So self dot linked list. I'm going to give it 2 Sential nodes, right? Uh, yeah. So okay, or just one thing. Let us start at the head. So the most recent one is what we'll go for. So initially it's just nothing, it's null, right? Yeah, so it will just be none. So this will be a bit like a normal linked list, except yeah, right. Okay, so get, what does that do? And the dictionary isn't pointing anything, so okay. So if I don't want to do in directly, I guess. No, I mean it's fine because it's just a dictionary, so it doesn't matter. Yeah. So if key not in D, in that case you can't get the thing, so you just return none, I suppose. or returns -1. So it will be like return -1. Otherwise, you just return the thing. So it will be just like return the self.d thing, so self.dictionary key and the value. So this is the list node, and then I just want to return the value. Right, just the value. Fine, cool. So it also has a key. Why does it also have a key? I don't know actually. Good question. Anyway, we'll figure it out later. And for put, so first, if it's already there, so if key is in, so if key in the dictionary, in that case, what you want to do, right? Or you could just say, okay, so the node, new node, nn, that's going to be equal to just the thing, so it's t sub key, right? Else, you want to insert a new node, so nn is a node, so it's just node. And what you have to give is the value, and yeah, just the key and value. So the key is just the key, the value is the value. Yeah, right. So now you have the new node. You want this to be the most recent. Before that, the capacity. So if the capacity is already full, so if capacity, self.capacity. Oh, you also have to do that, right? Self.capacity. Capacity, right? Yeah, and you also have to do the length thing. So self.current capacity, that's just 0. So if the current capacity is, oh, and getting doesn't change the capacity, but putting does, right? Yeah, okay, so I'll just do this thing, and I'm assuming you just already like have it. So this, and then also change the capacity. So it's like self.current capacity plus equal to 1. So if this thing is bigger, it's going above the actual capacity, and that's bad. So you want to evict something. So what will you evict? You'll evict the least recently used, which, so since we're starting with the most recently used, okay, no. Yeah, you should be having the least recently used as the thing. So let's just say that L is like the least recently used. So least recently used, that's just self dot L, right? So if this is none, in that case, there's nothing to, I mean, okay, if this is none, you can't actually evict in the first place because you don't have reached that capacity. Yes. So you must have something. In that case, you just evict a thing, right? So you'll be like, yeah, right. Yeah, I mean, that's the thing. So it's just like self dot L is basically LRU dot next, or you could say whatever is more recently used in that, and we just don't care about the LRU. So LRU dot more is none. Yeah. Okay, and now the thing is we still want to update it, right? So we want that to be the most recently used. Think about it, think about it, think about it. So if it's already there, you still have it. So wherever it might be, yeah, we just need to, yeah, right. Okay, what if it's L itself? What if it is in fact the least recently used unit? In that case, the thing which is to the left of it is null, and then the thing to the right of it is something. Yeah. So what you'll do is just like you'll combine it, and then you'll move it to the other side. Yeah. Because now it's the most recently used. But you don't have to update the least recently used, right? Yes, that's a problem. So if this is happens to be the same thing, then Right. That's the problem. Okay. So, okay, if self.l is the same thing as the new node, so it's the same thing as new node, then that's problematic. So what you'll do is, yeah, you'll have to put it at the most recently used. Okay, where is the most recently used? Yeah, you also have to have that. So let's call it self.m. So that's going to be the last thing, basically. Right. Also, a get actually, yeah, that doesn't just return, it also changes the thing. Right. Okay, right now let's just focus on the put thing so that logic becomes more clear. So if the least recently used is NN, in that case, oh, you'll have a bunch of subcases for you. Yeah. So you basically just pull and then you have to change the other thing. So it's like self.l equal to nn dot more, whatever is the more recently used. Okay, what happens if it is the thing itself? That's a problem actually. Can't we just pull and, yeah, right. Just the starting value. But how to get the starting value? It's a good question. Whatever is the next thing, right? So if this is not null, then you just do that. So if, okay, so if nn not more is not null, in that case, the, yeah, that's just going to be the more thing, right? Okay, and then you can just pull. So nn dot pull, and then you attach it to the self dot more. So self dot m dot more. It's more than the more. That is nn. And at the same time, you update it like this. Cool. That's if this thing is nn. Okay. Else if this thing is not that, it's something else. Assume it's the more thing. In that case, what you have to do? Well, you remove the thing, then you add it to more, and there you go. That's the thing, right? Yeah. Well, if it is the most recently used thing, then you just leave it like that. Then just say pass. We don't care because it's already the most recently used. Okay. Otherwise, it's somewhere in the between, right? Yes. So in that case, what you'll do is just pull. So not self, not time, nn dot pull, and then you'll attach it to the more thing. So self dot m dot more equal to nn, and self dot m is nn. Yeah, that seems okay. So that's the put. Now you have to do the same thing with get. So if it's not there, return -1. Now if it is there, you're going to access it. So you will be doing the same thing, that if, yeah, this key was at the, yeah, okay, so first actually get the node. So node is just t key, right? Now if this thing, if this is the least recently used, in that case you have to do the same thing, right? Wait, why do I feel that something weird happened? Oh, this is a get thing that I did. Yeah. So I inserted a new node, but okay, so if the capacity is more, right? Okay, so if the capacity is, just remove the LRU thing, regardless. Yeah, and then do everything once again. That seems about right. Yes. Hey, what if the LRU thing is the thing that you want to add? Then you'll just remove it and add it again. I mean, it doesn't look that bad. Okay. So first you remove the thing, then you'll update. So nn dot value equal to whatever value, or you could just do it directly over there. Fine. So that's just updating the node itself. Then you are updating the least recently, so evicting something, and then you are rearranging correctly. Okay. Now here as well, you want to rearrange, right? So you know that the node was accessed. So you can do the same thing. Right. So if firstly the node is the leftmost thing, so it's like the least recently used. In that case, whatever is more than the node, if it's not none, then that's what this thing is, right? Because this is going to be the most recently used. And then you just say not pull, right? So it's just, yeah. Right, this is okay. If this thing is the most recently used, you don't really care. Otherwise, you just, so it's somewhere in the between. So you pull this and then you just set it to the most recently used, not caring what's happened to the other nodes. Right. Now, this is good in practice, but why do there's something missing? Okay, also input whenever you're, yes, you're incrementing the capacity, right? Doesn't seem too bad. Oh, also if it's not already there, you're going to do this, and you also have to add this to the dictionary. Important, right? And in eviction, yeah, right. If this thing is just not there, so if self dot, if so if the least recently used one, which is the one to evict, if this is not, so it's not the new node, right? The one which you want to add, because when that happens, this is problematic. If that's not the case, in that case, you'll remove the key from, yeah, yeah, right. I mean, it's already there if the key is there. Makes sense. So it'll just be like self.t. I guess it's delete or something. Yeah. Right, you can just completely forget it. It doesn't really have to matter. So the key, so it's just lru.key. Fine, I think that's okay. And right. I'm just gonna run this, forget testing or whatever. I'm pretty sure I'm gonna get something bad. Yep, as expected. Oh, come on. Right. How come I'm doing these mistakes? Oh, I also have to return something. Yeah, so you do all of this. Right, and then you return n dot value. Yep, don't forget that. And for put, you don't really return anything, right? Yeah, no. Cool. Let's try again. Okay. Now what's the, why do I keep doing this? Probably because I've been dealing with TypeScript a lot, so I'm like forgetting everything. Oh my god, what's going on? Yep, I'm just sorry. As I said, TypeScript. Been dealing with a lot. Yeah, I mean, I guess it's okay. I just hope this doesn't mess up again. Snow attribute capacity. Right. It's cap. Actually, let's just see if I need any more. No, it's fine. Okay. Oh yeah, I'll just have to do the null thing, don't I? Okay. So in the get case, it's just not there, so forget about it. Now in pull, if the least recently used and the most recently used, like both of them are like null, in that case, it becomes the same thing. Yeah. I think it's okay. Wait, so if the error not mode is none, in that case it's just like you don't even have to pull, I guess. Yeah, since you're putting anyway, so just don't pull, and that dot mode equal to nn. Yeah, that's correct. Okay, also, what was I doing? Yeah, right. So in putting, if this happens to be none, right? So if which by the way can only happen if there's nothing. So in that case, all you choose to do is like self.l, that is the new node, and self.m is also the new node, right? Yeah, I mean, I guess that's okay. Okay, and yeah, otherwise you do all of this. So it's an elif self dot, yeah. Otherwise, if this happens, otherwise if that happens. Fine, let's try again. This won't happen in get, right? Okay, once again, D is not defined. What? This is so bad. Oh, okay, that worked somehow. I'm pretty sure something bad is going to happen, but still, let's just submit it. Yeah, thought so. Let's use this test case. So it's a 3 capacity thing. You are going to say put, okay, what's expected was this thing, and I got something else. So I also want to console.log something, right? Yeah. Okay, not console.log, sorry. As I said, TypeScript. So just the key, so it will be like get the key, and for that what happened. So I'll just print the whole thing. So self.dictionary. Yeah. And for put, after all of this is done, that is, I'll just be like, okay, print, put the value, so just the key, and then what happened. Right, this should be doable. Okay, let's run this. Now time for some serious debugging. Okay, so first it's just initialize a 3 thing. Okay, now first it does put 1, so it's just 1. Oh, okay, this is not good. I don't want node object. So I'll have to have a represent for this thing. This is taking longer than expected. So the value, okay, the key, and then the value. Right. Or you could just say the value directly. Fine, let's run this again. Right, so initially it's just like put 1 1, so it's just 1, then 2, so it's putting for 1 it's 1, and then for 2 it's also the most recently used, then for 3 3, for 4. Right, okay, so it evicted the least recently used, which is 1, and so now you just have 2 3 and 4 as expected. Then uh, then you have 4 once again, so now this is there. Yeah, okay, this is problematic, isn't it? I instead want to have the, yeah, that thing itself. So I'm not going to print self.t. Instead what I'll do is I want to print the nodes, right? Okay, so I'll just be like list comprehension. Okay, this is probably a lot good idea. So I'll just be like nodes is, or values is more like it, right? I'll just be like top or some node n, call it n, is self.l, and while n is not none, just keep appending values to this thing. So just advanced dot append n dot value. What else you need to? And n dot, okay, so n equal to n dot more. Right, and then I'll just print the thing. So put key and then this list. So actually you should be probably putting both keys and the values, right? So a tuple is more like it, or more like a formatted tuple. Yeah, that's probably better. I can do the same thing over here. Just before the return, I don't need this. Yeah. Oh, okay, I'm returning n, right? That's problematic. So I'll just say, I know this is kind of patchy, but whatever. So to return is n dot value, and then I'll just return to return. Yeah, that's better. Now let's run this. I still don't know what went wrong though. Like, it's a simple LRU cache. So okay, so it's 1 1, then 1 1 2 2 1 2 2 3 3. Okay, then you have 4, so it's 2 2 3 3 4 4 as one would expect, and then you're getting 4, so 4 stays at the top, sure. Then you're getting 3, so 3 is, oh wait, why did it evict 4? Wait, this is a get, right? No, wait, what? It's not a put over there. So it has 1 2 3 4 puts, 1 2 3 4, right? And then you have 2 gets, so which is 4 and 3. For third, it's, oh shit, it's all put somehow. Why is it thinking of it as put? Oh, because I just did it like that. Yeah, so it should be get. Sorry for that. Okay, so it's, yeah, when it's trying to do get 4, it's fine, but then at get 3 it isn't fine, it does something weird. So let's think about what's happening at get 3. So after get 4 it's completely fine. After get 3, so it's somewhere in the middle, it's going to pull, right? And now I want it to be at the more thing. Yeah, so the self dot more thing is still what it was previously, right? Okay, let's see what happened. So when you do get, it's in the else thing, right? So n dot pull and self dot m dot more equal to n. Yes, and this should have attached it to the 4 4 thing. Huh. Unless that isn't m. Right. Yeah, but how is that possible? So let's just do it with get. Okay, that's there. And now I'll just say tab, and more is self dot m dot key. Yeah, this should tell us something. So after get 4, more is 4 4, okay, which is what you would expect. And when you try to do get 3, more is, so, oh, okay, so the more is 3, okay, we just did pull, that should technically be, yeah, but 2 2 didn't get attached to that somehow. That's bizarre, isn't it? Right, let's see what the pull thing is doing. Yeah. This is correct. Oh, okay, this is the problem, I think. Yeah. So I just don't need this. So, okay, you don't want it to be unattached, right? But, oh, okay, so you will have to still attach to something. Right. Right. Now I get it. Now I get what happened. So, uh, so after you do pulling, okay. Right, self dot L is n dot more. So this is just the get thing. And then you do n dot pull, and so this has have to happen, but at the same time n dot less equal to self dot m. This is what I didn't. Yeah, that's a problem. So I should have made more methods or whatever. But this is the problem, right? So the more, so every time that you will do this, right, you have to do that. And I guess here as well. So cc plus equal to 1 t key larry dot more is none. Okay, that's not important, I guess. Some just removal stuff, not interested. Right, this is very good thing. So you pull, then attach, but you attach both ways. Yeah, this is the better thing to do. Now let's try doing it again. Yep, that works. Now I don't need any of this over here as well. And yeah, I'm gonna run it again and submit. Cool. Now let's submit. Oh, come on. Key error. Okay, a bunch of puts and gets and the hell. So when you are trying to put, that is, so LRU dot it didn't exist. Oh, okay. When you're deleting it, you also have to decrement it, right? Yeah, I get what's happening. Okay. Right. And otherwise, whenever you do this, yeah, just increment it by one. Fine. Create a new node. Let's use this and let's try to do it again. Okay, that works. Stupid errors. But then these stupid errors cost a lot. Okay, cool. So that was, I think my battery is going to die. So yeah, I can't keep on going. So I'll see you guys in the next video. Bye.